Hello and good morning. Here we want to do an exercise in dynamics which is suitable for years 17, 18 and above. So the diagram shows a smooth circular arc AB which subtends an angle of 30 degrees at the center. And A is on a level with the center of the circle. And P is a particle which starts at A, moves down the arc, and leaves at B into free space. Okay, the particle starts from rest. Okay. And we want to find what the latest rectum of the parabola will be when the particle leaves the smooth curve AB. Okay, so first of all, starting from rest, the loss in height when moving from A to B is r sine theta, which is r over 2. And so the potential energy loss is mg r over 2, if we assume that the mass of the particle is m. Now the Ke gain will then be mgr, assuming there's no friction. So half mv squared, that will be the final velocity before leaving the curve, half mv squared will equal mgr over 2. And so v squared is gr, and v will be the square root of gr. So that's the initial velocity of the particle when it leaves the curve. And you then want to find the subsequent motion. So let the horizontal motion be given by x and the downward vertical motion by y. Then using basic laws of motion, we have x equals gr cos theta t, because there's no horizontal force acting, and that will be square root of gr times t over 2, because 60 is 2. And y will equal square root of gr times square root 3 over 2 times t, square root of 3 over 2 being the cosine of 30, plus half gt squared. Now, the only part in the second equation that we need to concern about ourselves about is the half gt squared. And half gt squared, we want to find the value of that when t equals 2x over square root of gr. We get that from the first equation. And then half gt squared will be half g times 4x squared over gr, which comes to 2x squared over r. And the latest rectum is simply the reciprocal of the x squared term, which will then be r over 2. And that does it. And thanks very much for listening.